Hello, I am Dr. Anubha Gupta from ABES Engineering College, Ghaziabad. I am presenting lecture series on electromagnetic theory. In my previous lecture, fifth, I discussed about the property of electromagnetic waves, that electromagnetic wave have transverse nature. In this lecture, topic to be covered, relation between electric and magnetic field of EM wave. Before starting this relation, I will discuss the third property of electromagnetic wave, and we as we know that the electromagnetic wave have a three vectors. First is the electric vector E and magnetic vector H and the propagation vector K. So the third property of electromagnetic wave is that these three vectors are mutually perpendicular to each other. This is the third property of EM wave, and it is also called orthogonality of EM wave. So before going to this topic, I will discuss the some basic concept of vector calculus. जैसे कि आप सबको पता है कि वेक्टर्स में अगर हम दो प्रोडक्ट का क्रॉस प्रोडक्ट लेते हैं, अगर ये कोई प्लेन में वेक्टर ए है एंड किसी प्लेन में ये वेक्टर वाई प्लेन में वेक्टर बी है, इफ आई विल टेक द कर्ल, अगर मैं इस एक क्रॉस बी का कर्ल लेती हूँ, सो बाय द स्क्रू रूल द वेक्टर द रिजल्टेंट वेक्टर विल बी वेक्टर सी विच हैव द डायरेक्शन जेड. सो अगर दो वेक्टर का क्रॉस प्रोडक्ट थर्ड वेक्टर के बराबर होता है, तो रिजल्टेंट थर्ड वेक्टर होता है, तो हमें वेक्टर कैलकुलस से मालूम है कि तीनों वेक्टर जो कि परपेंडिकुलर हैं, तीनों वेक्टर एक दूसरे के परपेंडिकुलर होंगे. ये हमें रिलेशन पता होता है. सो इसी रिलेशन की हेल्प से हम ऑर्थोगोनैलिटी प्रूफ करेंगे. We know that the condition for the Maxwell equation in free space, कंडीशन ऑफ फ्री स्पेस क्या होती है? रो जीरो, सिग्मा इज जीरो, म्यू इज इक्वल टू म्यू नॉट एंड एप्सिलॉन इज इक्वल टू एप्सिलॉन नॉट. On the basis of these conditions, what are the Maxwell equation? This is the del dot E is equal to 0 and del dot H is equal to 0. And the third equation is del cross E is equal to minus mu naught del H by del T. And the fourth one is del cross H is equal to epsilon naught del E by del T. In this third and fourth equation, what we can see that del cross E is equal to third vector, that is the H. मीन्स जैसा कि मैंने यहाँ पर पहले भी बता दिया है कि अगर दो वेक्टर का क्रॉस प्रोडक्ट थर्ड वेक्टर के इक्वल होता है, इट मीन्स तीनों वेक्टर परपेंडिकुलर होते हैं. इट मीन्स डेल इज जस्ट लाइक अ पोजीशन वेक्टर. आई ऑलरेडी प्रूव इन द प्रीवियस लेक्चर दैट डेल इज इक्वल टू आई के, and this is the E and this is H, means K cross E is equal to the third vector which is H. So with the help of this relation, I am going to prove that how to take the curl of equation, this equation third and equation fourth. So before taking the curl, we know what is the del. Del is the I del over del X plus J del over del Y plus K del over del Z. And what is the E? Vector E is the E naught, e is the power I k dot r minus omega t. जहां पर E naught क्या होता है? E naught is the E naught x. This is the magnitude of electric field vector in all three direction. I j eo y plus k eo z. And what is the k dot r? K dot r is kxx kyy plus kzz. This is the k dot r. So if I solve del cross E, it will be solved with the help of determinant. So how to solve determinant? Del cross E. I j k. And the x component of the del is del over del x, del over del y, del over del z. And E is the E naught x, e is the power I kxx plus kyy plus kzz minus omega t. And what about the EOY? E is the power I kxx plus kyy plus kzz minus omega t. EOZ E naught e raised the power I kxx plus kyy plus kzz minus omega t. So after solving this determinant, I will get ik cross e, because we know that the del is equal to ik. So after solving this, we will get del cross e is equal to ik cross e. So left hand side, del cross E is equal to IK cross E. And at the right hand side of the equation third, there is a minus mu naught del H by del T. So now I will solve the right hand side. Right hand side is minus mu naught del H by del T. And similarly, we know that what is the value of H? Value of H is the H naught e raised the power I k dot R minus omega t. I will differentiate with respect to t minus mu naught. It will be minus I omega H. On differentiating it with respect to t, I will get this. So equate the left hand side and right hand side. It is equal to I k cross E is equal to mu naught I omega H. And it k cross E, k and E are the perpendicular to each other due to the transverse nature. So the magnitude, in terms of magnitude, it can be written as k E sine 90, and it is equal to mu naught omega H. And ke is equal to mu naught omega H. And this E by H, this is called the relation between the electromagnetic wave. The ratio of electric field vector to the magnetic field vector is equal to mu naught omega by k. And we know that the omega by k is the velocity. It is the velocity. So what is the E by H? E by H is equal to mu naught omega by k. And the electromagnetic waves are travels with the velocity of light. So omega by k value is c. So E by H is equal to mu naught, and c can be written as mu naught epsilon naught, which is equal to mu naught upon epsilon naught. And after solving E by H, the value of mu naught is the 4 pi into 10 to the power minus 7. And the epsilon naught is the 8.85 into 10 to the power minus 12. After solving it, it will be 376.7, 376.7 or 377 ohm. Why the unit is ohm? As we know that the unit of E is the volt per distance, volt per meter, and the unit of H is the ampere per meter. So by this we can say volt per ampere means it is the unit of ohm. So the ratio of E by H is called the Z, and where Z is the intrinsic impedance. Z is called intrinsic impedance of free space. Means whenever the electromagnetic wave travels in a free space, this is the impedance by the free space, which is equal to 377 ohm. And this is called the relation between electric field and the magnetic field vector. So to prove this relation, first of all, we show that there is a orthogonality between the this shows that the k, E and H are orthogonal. It shows that k perpendicular to H perpendicular to E. It shows the orthogonality. Similarly, we can show by the equation 4. And after proving the orthogonality, what we did? We proved that the ratio of E and H is the 377 ohm. These are the references of my lecture. Introduction to Electrodynamics by David G. Griffith, Solid State Physics by S. O. Pillai, Engineering Physics by S. K. Gupta.